So that's like stage two is like, can you grow tissue? And then once you have that, then I can fix your broken parts or regrow limbs or, other things like that. And then stage three is the engineering. And there, the lowest floor is called a plasmid. And there's a company called MiniCircle down in Roatan that does this a lot. And you could actually use plasmids to make pretty much anything. They're like little molecular factories. So I suffer from gout. 344 million people do. It's a genetic disorder, and it means my body doesn't process uric acid properly. And so what ends up happening is the uric acid over time, if I don't get it out of the system through some means like allopurinol, it'll accumulate in the joints and you have gout attacks and they flare up with crystals and it's super fucking painful. They just stab you, when you're walking around. It's one of the most painful conditions you can have. And if you don't treat it, it gets progressive. So it starts from the big toe to the joint, to the knee, to the hip, and then eventually your hands and the whole body. So you got to solve it. Well, there's a chemical it's an enzyme called uricase. And humans don't make it, but it exists in nature. And it digests uric acid and converts it to a water soluble, kind of like vitamin C, where you just pee it out, allotonin. So what if I made a plasmid that made uricase? Then I could inject it to a person who has gout. And now you have a natural way of processing the uric acid, so you never have gout. It's basically a cure. It's pretty cool. And so there's all classes of diseases where your genetics don't allow you to make something because you lost the lottery and they're slowly killing you. And so gene therapies are coming online. And what's really cool is like within 5 to 10 years, we'll actually start having those treatments available and they're there. And then you can also use it for therapeutic interventions. Like the MiniCircle is using it for follistatin 344, which is this chemical that basically allows you to build muscle. It turns off muscle inhibition. So if you see like pigs with it or cows with it, you can Google like muscle pig. And you see like this picture is just fucking jacked up pig. It's just looks like a damn beast. And so that's their first product is the muscle pig plasmid. So you inject the person with follistatin and they just start building muscle like crazy with it. And what's cool is the plasmids only last like a year or two and you can turn them off. You're using antibiotics. So they take it and kills the plasmid.
Wow.
Yeah, it's just crazy stuff. Well, the next thing they're looking at is TRT, testosterone replacement, and they're looking at HGH, human growth hormone, as another option. So maybe that's a better way than, dosing or these types of things. Because the next step with the plasmid is can you create an internal regulation system? So like insulin regulation with your pancreas, it makes it when you need it, and then it turns it off when you don't need it. So you get a constant level instead of having to inject yourself with, something with it. So, but once you have the platform, you kind of build your way up there and you get there. But the foundation of the platform is lifestyle. You have to eat right. You have to exercise. You have to sleep right. And you have to have good mental health. If you don't, you're dead. And then the next level up is saying, okay, regenerative intervention. So hyperbarics and stem cells. And then as you move up, there's replacement parts. And as you move up, gene therapies for these types of things. But you can just kind of walk the stack. Every step of the way, though, you get to health span. Longer lifespan and more comfortable life throughout. So it's not to make you immortal, but it's to say, hey, in your 80s, you're not a frail person, scrunched over and you can't move. In your 80s, you're walking around. You're having fun. This is how Peter Attia thinks about life. He says, hey, you should think about the proximal decade of your life, the last 10 years. And you should say, okay, what do you want to do in the last 10 years of your life? You want to be able to walk by yourself without a walker? You want to be able to swim for half a mile. You want to be able to, feed yourself and clothe yourself. You want to be able to take showers unassisted. You write those things down. And there's a formula, and you have to crank up and say, okay, how much muscle do you have to enter your 50s and your 60s in? Because it's really hard to build muscle after your 60s. What type of foods do you need to eat? What type of sleep do you need to have? What type of other interventions do you need to do? And then that'll tell you basically what you need to do every day to be able to get to that point in the proximal decade. Well, I think of it that, but I say, well, maybe I'll give you a little bit of help because not everybody's Ned Flanders and they're going to fucking do everything right? Sometimes we like our hard whiskey and fast women and, bad, stressful situations. The best ex-wife I never had, right? Sometimes we like that stuff. So the stem cell part is about correcting the problems that we had, and hyperbarics is about correcting the problems we have. And what's really magical about it is the AI is helping tremendously. We're able to do literature review, especially from the Chinese papers, because the Chinese have so many of these guys working on this, and they just trained more scientists than we did. But you can't read the papers because they're in Chinese, or even when they're in English, they're very inaccessible. So we were able to take pretty much every paper ever written in China and every paper written in other jurisdictions and run it through AI models and say, well, who's working on this thing and who's working on this thing and what were their experimental results that they got. And it gives you some indication of what's working and what's not working. And it's already paid huge dividends and a lot of the research that we've done. And I'd say just the last 2 years in particular, we've probably done 5 or 10 years worth of desk work, for this. And I have a lot of MD PhDs that work for me. So they do the translational medicine. So they're able to take the basic science and then translate it and say, this is what would be required for a human trial. And here's how many patients you need. And here's how the FDA is going to get happy. And, these types of